Friends, most oil tests talk about aging. Some talk about insulation strength. But Flashpoint talks about fire safety. Flashpoint does not tell you how old the oil is. It tells you how dangerous the oil vapors can become. If Flashpoint drops, it means volatile components are increasing, often due to contamination, thermal stress, or oil degradation. That is why Flashpoint is a mandatory safety parameter in every transformer oil standard. In today's Electroverse episode, we decode what Flashpoint actually means. Difference between Flashpoint and Firepoint. IEC 60296 minimum requirement. ASTM test methods used. Why falling Flashpoint is a serious warning. And how engineers decide oil rejection based on Flashpoint stay till the end. Because fire risk is not negotiable in power transformers.
When we think about power transformers, we often focus on their electrical performance. But here's something that might surprise you. A transformer doesn't just fail electrically. It can fail violently. And that's where understanding Flashpoint becomes absolutely critical for every engineer working with these machines. Flashpoint is the lowest temperature at which transformer oil vapors will ignite momentarily when exposed to a flame. Think of it as your early warning system for fire risk. This isn't about sustained combustion. It's a warning temperature that tells you how volatile your oil has become. And in the world of transformer safety, this single parameter can mean the difference between a manageable fault and a catastrophic fire. The test we use is called ASTM D93, also known as the Penske-Martin's closed cup method. This is referenced in both IEC 6296 and IEC 6422 standards. We use the closed cup method because it best represents real transformer conditions. Your oil is sealed inside the transformer tank, just like it's sealed in the test cup. This gives us the most accurate picture of what's actually happening inside your equipment. Now let's talk about what these numbers actually mean. According to IEC 6422, if your Flashpoint is above 140 degrees Celsius, your oil is in healthy condition. Between 130 and 140 degrees, you're in the caution zone. Below 130 degrees, that's unacceptable and dangerous territory. These aren't arbitrary numbers. They're based on decades of research and real-world transformer failures. Here's what many engineers don't realize. Flashpoint reduction isn't normal aging. When you see that number dropping, it's telling you something abnormal is happening. Oil contamination with light hydrocarbons, internal arcing, mixing with incorrect oil types, solvent or fuel contamination, or severe thermal cracking. Each of these scenarios creates volatile compounds that lower your Flashpoint and increase fire risk dramatically. But the real danger comes with sudden changes. A gradual decline over years might indicate normal thermal stress. A sudden drop? That's your transformer screaming for help. This indicates internal arcing, oil cracking, or fuel-like contaminants present. This condition demands immediate action. You cannot afford to wait or hope it stabilizes on its own. When you encounter a low Flashpoint, IEC 6422 gives you a clear action plan. First, immediately correlate with dissolved gas analysis. Check if your oil identity matches what should be in there. Assess the fire and explosion risk honestly. Then plan for oil replacement or equipment isolation based on what you find. These aren't suggestions, they're engineering imperatives. Flashpoint is fundamentally a safety parameter, not a performance parameter. Your transformer might run perfectly fine today with a low Flashpoint. The oil still insulates, still cools, still does its daily job. But Flashpoint decides what happens during a fault. It determines whether a simple internal arc becomes a manageable event or turns into a violent explosion that destroys equipment and endangers lives. The history of transformer failures tells us everything we need to know. Many transformer fires were preceded by low Flashpoint readings and ignored safety warnings. Engineers saw the numbers, noted them in reports, but didn't act decisively. They are focused on dissolved gas analysis, power factor, and other performance metrics while overlooking this critical safety indicator.
You cannot see Flashpoint with your eyes. You cannot smell it or feel it during routine inspections. But it's there, silently determining how dangerous your next failure will be. Low Flashpoint means fire risk exists. Period. And sudden change is always more dangerous than gradual change because it indicates active fault conditions rather than normal aging processes. This is why flashpoint testing exists in every major transformer oil standard. It measures oil safety, not aging. It tells you about volatility, not electrical performance. And it gives you the information you need to prevent catastrophic failures before they happen. Never ignore safety parameters. They exist for a reason, backed by decades of engineering experience and real-world failures. Flashpoint might not affect your transformer's daily operation, but it absolutely decides what happens when something goes wrong. And in the world of power transformers, being prepared for that moment isn't just good engineering. It's essential for protecting equipment, infrastructure, and human life. Understanding flashpoint isn't just about following standards or checking boxes on maintenance reports. It's about recognizing that transformer safety requires the same attention and expertise as transformer performance. Because when a transformer fails violently, all the electrical performance in the world won't matter if you haven't paid attention to the safety warnings your oil has been giving you.
So friends, this is the real meaning of flashpoint. Flashpoint is not about performance. Flashpoint is about safety margin. Remember these rules forever. High flashpoint, low fire risk, falling flashpoint, volatile contamination, flashpoint below standard, oil rejection. Flashpoint does not recover by filtration alone. Once it drops significantly, the oil's fire safety margin is compromised. If this explanation helped you understand why flashpoint is critical, support Electroverse. Like this video. Comment below, have you ever seen flashpoint failure in service? Subscribe, because next we close oil testing with Firepoint and Safety Matrix. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.